So going through the thoracic limb, it's important to know that there is no direct connection between the thoracic limb or the forelimb and the axial skeleton as far as there being any bone. The thoracic limb is actually held on at the scapula through muscles, tendons, and ligaments to the axial skeleton, so to the ribs and to the thoracic vertebra, and specifically the dorsal spinous processes of the thoracic vertebra. The thoracic limb is going to consist of starting proximally at the scapula. From the scapula, we go to the humerus. The humerus, you have two bones that run together called the radius and ulna that will go to the carpus and the carpal bones. From the carpal bones, we have the metacarpal bones, and then last we have the digits or phalanges. So starting at the scapula, it is a flat bone. They say it is somewhat triangularly shaped. The main features of the scapula are going to be the supraspinatus fossa and the infraspinatus fossa, along with the spine. The spine is what we call a lot of times the shoulder blade. You have a lot of muscles that actually attach here that are important for moving both the shoulder and the elbow. And then also you have a lot of muscles that attach here that actually will hold the thoracic limb onto the axial skeleton by attaching to both the ribs and also attaching to the thoracic vertebrae along the dorsal spinous processes. We do have the neck, which is where these fossas and the spine kind of stop at before getting to the shoulder joint and the glenoid cavity. The very end of the spine, we have a place called the acromion that a lot of muscles that actually move the elbow attach to. And then the humerus is actually going to articulate here in the shoulder joint. The head of the humerus is going to be up here in this concave area known as the glenoid cavity. The humerus is the long bone of the brachium. It consists of the head, which is going to articulate in with that glenoid cavity of the scapula. Just cranial in front of it there, we have the greater tubercle. Notice there is no space here between the head and the greater tubercle. The greater tubercle is where we have a lot of muscles attached to that are going to move both the shoulder, and they're also going to be important in moving the elbow. Right below the head, we have the neck, and then going down from the neck, you're going to have the shaft, and it's going to go down here to the condyles. When we get to the distal end of the humerus, we have a depression on the caudal surface called the olecranon fossa. And the olecranon fossa is where actually the olecranon process of the ulna will actually move into when the elbow is being flexed and extended. There are two condyles distally here on the humerus, and we call them the trochlea and capitulum. The trochlea is actually the medial condyle, and this is actually where the ulna will ride on. And then laterally we have the capitulum, and this is where the radius will actually ride and have pressure put on. On the side of the humerus, we have epicondyles, and so epicondyles are the processes that you can feel associated with the condyle. So these are actually landmarks you would feel if you were trying to find the joint for, say, taking a radiograph. The antebrachium is formed by the radius and ulna. These bones actually run side by side. The ulna is not weight-bearing or has very little role in weight-bearing. It is actually used more for support of the muscles and for helping to move the elbow joint. When we look at the ulna, we're going to have several key features on it. First is this olecranon process that's actually going to come out and extend at the elbow to the caudal side of it. It's what a lot of people will call the funny bone. We actually have the trochlear notch here, which is actually the portion that's going to ride and allow for movement of the elbow on the humerus. And then distally, we actually have the styloid process down here, which can be felt at the carpus or wrist. The radius is the main heavy weight-bearing bone. It actually has an articular surface proximally with the humerus to make the elbow. And then distally, we also have the medial styloid process down here, which can be felt on the inside of the wrist. Next, we come to the carpus, and the carpus is comparable to the wrist in the person. We do have slang for it in cattle and sheep and horses and large animal. They call it the knee. It is not actually comparable to your knee on your pelvic limb, but that is just a layman's term that's used. Properly in medicine, we do call it the carpus. It consists of two rows of bones. The proximal row of bones are going to consist of, on the lateral side, starting at the accessory carpal bone, and then we go to the ulnar carpal bone, the intermediate carpal bone, and then most medially ends up being the radial carpal bone. The second row of bones we just call these the carpal bones, and then we give them numbers. Number 1 is going to be the most medial, and carpal bone number 4 will be the most lateral. Extending from the carpus to the digits are the metacarpal bones. Depending on the species is how many of these metacarpal bones there are. In the dog, there will be 5. Where the dew claw's at, the most medial one is going to be the first metacarpal, and then the most lateral one is going to be the 5th metacarpal bone. And all of these will end up hooking up to the phalanges or the bones of the digits. When we look at the horse has 3 metacarpal bones, but only one is weight-bearing, and that is their 3rd metacarpal, otherwise known as their cannon bone. At one time, horses had 3 toes, but evolutionarily, they have evolved to have just one main weight-bearing carpal bone, and then we have 2 what we call splint bones, and so these are just vestiges that were weight-bearing, but they're not anymore. And so these are actually metacarpal 2 and 4. So this would actually be number 4 right here on the lateral side, and this is number 2 on the medial side. The main weight bearing again is the cannon bone or the 3rd metacarpal. Cattle have metacarpal 3 and 4 when they're young. These bones are actually 2, but they fuse as they grow into one bone, and so it looks like they have one main cannon bone that actually is bearing weight, but it actually starts off as 2 bones and fuses into one. And from there they have their 2 main weight bearing digits, which they actually walk around on their 3rd and 4th metacarpal bones, and then their 2nd and 5th metacarpal bones are not present, but they do still have what we call dew claws, which are vestiges from when they had 4 toes. You can also see here the phalanges and the proximal phalanx, so this would be the first bone of the digit, the middle phalanx, which would be the middle bone of the digit, and then the distal phalanx, also can be known as the coffin bone, and livestock, which is the most distal of the bones of the digit. When we look at horses, they have just one digit going all the way down. So you come here from the metacarpal bone. So this is the carpus, 3rd metacarpal. This would be the splint bones, which are your 2nd and 4th, but they don't actually make it all the way down here to the fetlock joint. So this is the fetlock joint, or what's known as the metacarpophalangeal. Extending distally from there is the first phalanx, known as the long pastern bone, and we can also call that P1. The middle phalanx, known as P2, and we call that the short pastern bone. And then the 3rd phalanx, or the distal phalanx, known as the coffin bone. Also with the digits, we have sesamoid bones that are associated, and these sesamoid bones are important for actually flexing the digits and moving them. We have in horses the proximal sesamoids, which are important for supporting the fetlock joint here and actually helping to pick the digit up. And then we have the distal sesamoid, also known as the navicular bone. And this one here becomes really important for actually getting the toe off the ground. If you don't have this one here, the horse cannot actually pick their toe up off the ground. When we start looking at the phalanges and the distal portion of the limb in a dog and a cat, we end up having 5 digits. The very first digit, digit number 1 right here, is the dew claw. There is only the proximal and the distal phalanx, so they only have 2 phalanges, the proximal and the distal. And then on digits 2, 3, 4, and 5, we have the proximal, the middle, and the distal. One thing to note on both large animals and small animals, the hoof is totally surrounding the distal phalanges in a horse or in a cow, and then the distal phalanges in a dog and a cat actually have the nail, so their claw actually surrounding it. So that is an overview of the thoracic limb. Next we will do the pelvic limb.